Welcome back! In our NumPy neural network, we had several decisions to make. First, we had to select the best way to initialize the weights. Back then, we chose the starting points of the weights and biases to be random numbers between -0.1 to 0.1. Here, we left the default TensorFlow settings do their magic. In fact, if we want to make this example as close to the original as possible, we can set a random uniform initializer where we define the layer. Instead of having a single argument, output size, we can also add a kernel initializer and a bias initializer. Kernel here is the broader term for a weight. Okay, so let kernel initializer be equal to TF random uniform initializer from -0.1 to 0.1. Similarly, bias initializer would be equal to the same expression. Great! Naturally, you can specify other ways in which you want your weights and bias to be initialized, but more on that in later sections. What else did we explicitly specify in the NumPy example? Well, the learning rate. The learning rate is an integral part of the optimizer. Here we took the default stochastic gradient descent, or SGD. In fact, we can create a variable called custom optimizer equal to TF Kira's optimizer's SGD and specify several arguments. For now, the only one we know is the learning rate, so let's set it to 0.02 as we did in the NumPy example. Next, we should replace the string SGD in model and compile it with our new custom optimizer. The new result would be practically the same, with the small difference that we get to set the learning rate ourselves. Here, it's a good idea to note that you can always refer to the TensorFlow documentation and figure out how to customize your model. Okay, so far, so good. Now, the only thing we have left is the loss. Since matters are much more complicated in this course, we will use the built-in losses without customizing them. In the future, you may get hooked on neural networks and want to try out new loss functions. Rest assured, it can be done. However, it's rarely worth the trouble. All right, let's train our model with these tweaks. Unsurprisingly, the results are no different. Our weights and biases are also practically what we wanted them to be. The outputs are as close to the targets as they used to be, which is evident from their arrays as well as the plot. Okay, as we progress through the course, we will look into each building block in more detail, from layers through optimizers, learning rate schedules, initialization, and much more. Can't wait to see you there. Thanks for watching.